Good evening, kids. In today's class, we are going to discuss the resistor capacitor circuit one shot, or what you will call it as RC circuit. In that one shot, why I made this separately, sir? It's not a chapter; it's a subtopic. If you look at the JEE Advanced, we'll get 6 questions. Very, very important. Mains, okay, fine, one question. But JEE Advanced interlinked 6 questions, not one, two. This will be the most important. So let me focus separately this one. For JEE means only one question. So here, first again, what is the methodology? How to utilize this one shot? Watch it. Then, what all the important concepts, ideas I am explaining? You have to learn. Then, after learning, then what happen? You can start rereading it. When you go through it 3, 4, 5 times, then you start remembering. Then solve PYQ. You can be in a more confident. Your confidence level will be at higher level, and you can see the benefit. This type of preparation. This is called like a hard work. You have to put effort. Fine. Now, how to? What are the topics that are very important in this particular subtopic RC circuit? So resistor capacitor with a DC source one shot. Growth of charge in RC circuit. Then decay of charge in RC circuit. How the charge across capacitor increases and decreases. This is a thing. Then RC circuit with multiple loops. Like we will be using KVL. Then RC circuit with multiple capacitor problems. Then RC circuit with initial charge in capacitors. These are the and next again one more RC circuit at t equal to 0 and t equal to infinity, steady state. These are the next set of problems. Very, very important for advance. You can't skip this topic. It's a subtopic, it's not a chapter. Fine. So we will start with the basic RC growth of charge in RC circuit. Okay, fine. Okay, we'll start with the growth of charge in RC circuit. Initially, capacitor is not charged. The switch is closed. The battery is switched on at t equals 0. Then we'll discuss the problem. At t equals 0, we have switched on. Then the current starts flowing. This current starts flowing. Let this variable current I. The current I will flow here. Current enters. It leaves this one. So the end where it enters positive, where it leaves negative. Current. Here the charge will get deposited, plus Q minus Q. From here current I, and this is I. This is the flow of current. We'll apply the KVL. E plus C minus IR minus Q0. If charge across capacitor increases, then the convention is dQ by dt. If the charge across capacitor decreases, then I equal to minus dQ by dt. When do we use it? Charge increases. This is a convention. So therefore, here we'll write down this one. We'll replace I as dQ by dt. This everything will become integral of dQ dt by RC. Then at t equals 0, the initial charge across 0. At any instant of time, let the charge. After solving this, I'll get CE 1 minus e to power of minus t by lambda, where lambda is called as a time constant. Directly I'm writing it, time constant of circuit. Why time constant? It will have unit that of the seconds. Then after getting this charge, we'll get the voltage, the equation for voltage across the drop across capacitor, the drop across resistor. This will be Q by C, which is equal to E into 1 minus e to power of minus t by lambda. the drop across resistor will be I into R. What is I? I is equal to dq by dt. I'll differentiate this. I'll get the current. Here I'll write it here. I equal to dq by dt. This will become CE lambda e to power of minus t lambda. Lambda is RC. ER e to power of minus t lambda. This is expression for current. This is expression for voltage. This is expression for charge. You have to remember formulas, very, very important. If I plot this curve, the curve will be like this. Then expression for current, the expression for voltage across capacitor will be like this. And the current will be decreasing, exponentially will decrease. These are all this one. So what is the time constant? Time taken for the charge so this is the 1 lambda. Time taken for the charge to become 63% of final value. I don't have place. I'll write like this. 63% of time taken. What is how you define time constant? Time taken for charge across capacitor to become 63% of final value. What is the final value? Final value is CE. I'll move like this. Okay, agreed? Huh? So this is what we define the time constant. Then almost after 5 lambda, it will be almost a constant. This CE is called as a steady state charge. So what is the steady state charge here? Okay, this is a basic growth of current. Once it is fully charged, the switch is moved to the position 2. The same circuit will take it. No. Once the capacitor is fully charged, I'll move the switch from 1 to 2. Then here the capacitor will behave like a cell. It was having a charge, so it starts discharging. The discharging current will flow like this, plus minus. This will be the path. So the path, the discharging current will flow like this. There's a path it will take. There won't be current through the cell. Then we'll write down this one. So this will be applying the KVL, the loop equation, plus Q by C minus ID into R equal to 0. Q by C equal to ID into R. Q by C equal to minus dQ by dt. So this will become dQ by Q equal to it will start decreasing. Say t equals 0, what was the charge? Q infinity. At any time t, let Q be the charge. So then this will become log of Q by Q infinity minus T by RC, where RC lambda equal to RC time constant. So Q equal to Q infinity e to power of minus T by lambda. RC we are replacing by lambda. Log, if I send on the side, exponential. This if I differentiate, dq by dt, Q infinity by lambda e to power of minus T lambda. Then negative sign will come. The discharging current, Q infinity is what? CE. The steady state charge. Then this will be RC. So all the energy in the capacitor, finally when it becomes zero, all that will be taken by the resistor. So what is the heat generated across the resistor? That should be equal to Q infinity square by 2C. This is the heat generated in resistor. What all the energy in the capacitor, that will be taken by the resistor. So how the graph will be, roughly you can have the idea here only. The current through will decrease and finally will become zero. So this will be E by R. This will be T. This is discharging current. This is one again. You have come across formula. You have to remember this formula, very very important. And this is a heat generated. This is a time constant formula. Now at steady state, at T equals 0, how the capacitor will behave like a short circuit. Now, there's one small important idea. Then initial current I naught will flow. What is I naught is equal to? I naught equal to E by R according to the equation what we had. Then at T equal to infinity, or you better call this as steady state. At steady state, where all capacitor there, put open circuit. No current will flow, so the drop across capacitor will be that of the applied EMF. This is the open circuit. Here this will be short circuit. Then what is VAB? VAB equal to E. This is very important. At T equals 0, the capacitor will behave like a short circuit. At T equal to, after a long time, will behave like an open circuit, and it contains energy. How much of energy in the capacitor will be? C E square by 2, or it should be Q infinity steady state charge by 2C. This is energy stored in the capacitor. We have this RC circuit with multiple loops. There is a cell, resistor 3R, 2R, and there is a capacitance C. Initially, capacitor is not charged. Okay, now we have to calculate the charge across the capacitor at any time and current in all the branches. So, what is the many methods are there? We'll assume the current here. Let it be current here, I1. The main branch current, let it be I. Here, I minus I1. And there's a variable current, I minus I1. Okay, you can write the loop equation where current enters positive, where it leaves negative. Like this, you give polarity. Let any instant of time charge across capacitor be Q. Write KVL. Then afterwards, writing KVL. This will be plus C. I'm using this path E minus IR minus I1 to R minus Q by C 0. Then minus I1 to R minus Q by C plus 3R I minus I1. Then one more loop equation, plus C minus IR 3 I minus I1. Solving this, we'll get the required answer. And what is I1? I1 equal to dq by dt plus dq by dt. Why plus? Charge across capacitor is increasing. This is one method. Or other easiest method, we can directly get the steady state charge at t equal to infinity. At t equal to infinity, what is the capacitor? Capacitor will behave like an open circuit called AB. We'll calculate, and the total current, the current will flow only here. We'll calculate the VAB. So what is first? I is equal to, this I is equal to how much? I equal to E by 4R. Then we'll calculate VAB. VA minus 0 into 2R minus I into 3R minus VB 0. VAB equal to 3R into I. 3R. I is how much? E by 4R. Then what is the charge? The steady state charge is equal to C into VAB. 3CE by 4. Then we know charge and how to get the time constant. Then this is about the steady state charge. To calculate the time constant, what we should do, where all the cell is there, replace with its, make EMF of 0 and replace cell with internal resistance. There is no internal resistance, so this everything will become like this. Two R, 3R, and this is R. So the effective resistance as seen by this. So this will be 3R, 3 by 4R, RAB, 2R into 2R plus 3R by 4. As seen by the U stand here. And what is the effective resistance as seen by the terminals AB? These two are in parallel. That effective will be in series with this one. So this will be 11R by 4. Then what is the time constant? The time constant will be C into RAB, 11RC by 4. Then you can write expression for charge. No? Charge equal to Q infinity 1 minus e to power of minus t lambda. After substituting this, I'll get the charge in capacitor at any time t. This will be 3CE by 4, 1 minus e to power of lambda. This will be 4t by 11RC. This is the expression for differentiate this, we'll get the current I1. Huh? So what is the expression for I1? I1 will be 3CE by 4 11RC e to power of minus 4t by 11RC. Then expression for current will be T by lambda. Lambda is how much? Lambda is 11RC by 4, no? This will be 4 into 11RC. This expression for current will be I1 equal to C will get cancelled out. 12 E by 11R e to power of minus this expression for the current I1. Once you know I1, substitute I1 here, we'll get I. Then we'll get current in all other branches. There's a multiple loops will come. Either you can use this calculus method or use this particular method. I have circuit like this, so we have to calculate the charge across capacitor at any time t. Again, the same method. Let me go for I. Here I1, here I2, here I. Then give polarity. Then write down the loop equation. Let any instant of charge, let it be charge across capacitor be Qi minus Q. Then the equation will be plus C minus I to 2R, I into 3R, I into R equal to 0. Then writing equation here, Q by C plus, this is a positive plate. Let me, then I'll move like this, plus Q by C minus I2 into 2R equals 0. Who is responsible for the current? I equal to plus dQ by dt. Then what is the KVL equation equal to? I equal to I1 plus I2. Substitute this and you can solve it. I1 is responsible for dQ by dt. So we'll write one more loop equation. Plus C minus Q by C minus I into 4R equal to 0. What is I? I is equal to I1 plus I2. Okay, agreed. This I we should replace. I should be equal to I1 plus I2. What is I1? I1 is dq by dt. What about I2? I2 is this much. Then solve, we'll get the differential equation. By integrating, we'll get expression for charge across capacitor at any time t. Or at steady state, at t equal to infinity. I'll write this I1 here. Another method, at steady state, how the capacitor will be open circuit. We'll calculate the drop here. A constant current I will flow. What is I equal to E by 6R? Then what is the drop? VAB is equal to VAB equal to I into 2R. E by 3. Then the charge Q infinity equal to C into VAB. C by 3. Then what is the time constant? How to find out the time constant of circuit? Time constant of circuit you have to find out in this way. All these things I'll write it here. I is equal to I1 plus I2. Applying KCL at this point. Now, come for how to calculate the time constant of circuit. Where all cell is there, replace with a short circuit. Then it will be like this. This will be R, 3R, 2R. The cell EMF we have made 0. Then effective resistance will be 4R parallel to 2R. 4R parallel to 2R. 4 2 ja 8, 8 by 6, 4R by 3. Then time constant of circuit will be RAB into C, 4RC by 3. Then what is the expression for charge? Charge equal to Q infinity 1 minus e to power of minus t by lambda. Then differentiating this, we'll get the current I1. You have two approaches. This one approach, this approach is, if you're not good in calculus, if you know calculus, use this one. If you know the differentiation integration, use this one. Or this is by steady state approach. So where all cell is there, you have to replace with a short circuit or replace with internal resistance. There is no internal resistance of the shell, 0. Therefore, we are replacing with a short circuit. So where all cell is there, that you have to replace with a short circuit. Okay, multiple loops. This is a basic idea. We have the multiple capacitors. Here the current I1 will flow, current I2. Here the main branch current I will flow. This I will break up here, I1, and this is I2. Again it will combine. What is the expression for I1? I1 equal to E by R1 e to power of minus T R1 C1. Separately, the current in this will depend on these two resistor capacitors. The current here will depend upon ER2 e to power of minus TR2 C2. Next we have there's a capacitor with initial charge where condition given Q0 less than C. At any instant of time, let the charge across capacitor, let it be Q minus Q, and let the current be I. Then writing KVL, E minus Q by C minus IR equals 0, where I equal to dQ by dt. Then this solving will end up equation of like this, dt by RC. At t equals 0, what is the charge in capacitor? It is Q0, no? Substitute that charge. At an instant of time, let it be t. If there's some initial charges present, then this equation will become log of CE minus Q by CE minus Q naught is equal to minus T by RC. This will become CE minus Q okay, fine. So this is the expression for charge initial. If initial charge is present, this is a basic method you have to apply it. Put equal 0, then what is the charge? Charge will be Q naught. After a long time, what will be the charge? Will become equal to CE only. What is the steady state charge? This is a steady state charge. This is a RC circuit with initial. Next, one more condition. I have the capacitor, the plates of capacitor are given charges Q1 and Q2, and switch is closed. We have to calculate the charge in the capacitor at any time t. So when you close this switch, after some time, the charge will be, how much of charge will be there? The initial at t equals 0 will discuss first. This will become Q1 plus Q2 by 2. Q1 minus Q2 by 2 minus of Q1 inside minus Q1 Q2 by 2, and again outside Q1 Q2 2. These are the charges. When you close this switch, the charge will be this. So this charge will not get disturbed. Only this charge will change. So this charge will remain as it is. This charge will not change. Only the charge inside the capacitor is going to decrease. So this will become Q is equal to initial charge how much? Q1 minus Q2 e to power of minus T by RC. This is a discharging. So when the plates of capacitor are given different charges, there is a basic method. RC circuit with multiple capacitors. RC circuit with multiple capacitors. There is a battery. This is having a charge, initial charge Q naught. This is uncharged. There is a charged capacitor. I'll close the switch. We have to calculate the current through this circuit at any time t. Once we get the current, we'll get the charge here. So after closing switch, the whole circuit will be, no, I'll close the switch. This Q naught charge is there. This will become Q naught plus Q, and here charge Q minus Q, and the current, let it flow like this. The current will take path here. The current will take path. So then we'll see that one. How the capacitor will behave like a cell at that instant. If it is uncharged, it will behave like a short circuit. We'll calculate at t equals 0, we'll calculate the current. At t equals 0, where all capacitor is there. Charged capacitor you should replace with a cell. Then the uncharged capacitor you have to replace with a short circuit. This is a very important concept. Hope you are getting now. So what is this battery? This is applied EMF. This is due to capacitance. The 2C capacitor will behave like a cell. Then how much of EMF of this will be? Q naught by 2C. There is a resistor, there is a capacitor short circuit. Then the current initially I naught will flow here. We'll assume that Q naught less than C. So the current will initially flow like this. Then this will become plus E minus Q naught by 2C minus I naught R equals 0. So I naught is equal to, now I naught will be E minus Q naught or 2C E minus Q naught by R. Then at any time t, so we'll write down the equation. At any time t, this will be plus C minus Q naught plus Q by 2C minus IR minus Q by C equals 0. Differentiating this, dE by dt. Q naught is a constant, so this will become 1 by 2C dQ by dt minus di by dt minus this will become dQ by dt into 1 by C equal to 0. This will be constant. Then this will become I by 2C. This will become 1 by R di by dt minus I by C equals 0. Now further we'll solve it. This will become I'll put bound here, it will be easy for you. Now further simplification will be 3I by C equal to di by R dt. R, capital R will be here, or di by I is equal to dt by negative sign, let it be here. At t equals 0, what is the current? I naught. At any shift of time, let it be I. This is a method, so this will become log of I by I naught equal to minus 3t by RC. This is the expression for current. Then I equal dQ by dt, then we'll get the charge. So one charge capacitor, another charge capacitor there. So we have to use this method. So now what is this? Cell and there is a short circuit. Uncharged capacitor, short circuit, charged capacitor through a cell. There's a one multiple thing come, there's a method you have to apply it. Fine. Now we have to calculate the steady state charge across this capacitor. At t equal to infinity, we'll draw the circuit. After long time, what will be the capacitor? Capacitor we have to replace with the open circuit. Already you know the method. So where all capacitor there, I'll replace with an open circuit. Where there is open circuit, no current, so the current will flow only here. The path it will take is current I, this is I, this is I. The current will only take path like this. Then polarity you give it plus minus, I equal to 10 minus 5, 2 plus 3, 1 ampere. Then VAB minus 10 plus 3I minus 4 into 0 minus VB equal 0. VB equal to 10 into 3I. VAB equal to 7 volt. This is a method where all capacitor replaced with open circuit and find out the steady state charge. Okay kids, this is about the discussion. It's a very short, very small topic and very important for JEE Advanced. That's why I just give all the brief ideas. So please go through it, all the different conditions which are there, work out different types of problems. Really you can improve a lot using this basic methods. Almost all ideas I covered it. For JEE Main this is more than enough. For JEE Main this is more than enough. Okay, fine. I'll update coming I'll update few more topics. There are a lot of second year topics left over. I'll update one shot of that also, that one. So prepare well for JEE Mains as well as those who are preparing for JEE Mains. So have the concept clarity, formulas, PYQ. Those who are preparing for JEE Advanced, concept clarity, formulas, and you should explore more number of numericals. This is one basic methodology. Okay, thank you everyone. So I'll end up the session.